Hello. Good morning, everyone. All of you are there. Can we start now?
हाँ भैया प्रणाम। हाँ भैया सब ठीक जी जी हाँ नहीं ये वो तो आया था, वो तो एयरपोर्ट के बाहर ही मिल गया था जी। दरवाजे पर। हाँ भैया अरे ऐसे कैसे उठा लिया?
Yeah.
नहीं भैया नहीं आप टेंशन मत लो भैया, हम देख लेंगे। अरे हाँ हम देख लेंगे बिल्कुल। हाँ भैया
Yeah. So yesterday we were doing this question. Okay, arrange the following in the increasing order of stability, chemical bonding, right?
ले जाएंगे भैया, ठीक है भैया।
Okay. So what was the answer? Question number 2.
रंजन भैया
We were discussing this, no? Then power failure was there, so I could not complete it. So we'll finish it today.
बाबूजी मतलब तिवारी जी पूछ रहे थे क्या हाल है, मैंने कहा बढ़िया है।
So we were talking about the stability order of these resonating structure. Okay, and the first case that we had discussed on this stability of resonating structure is to calculate the number of covalent bond first. So according to that, the first compound, this one, third and fourth has equal number of covalent bonds, and in the first one the negative charge is present on the more electronegative element, that is nitrogen. So first one is more what we say, the first one is more stable, correct? So
सुरक्षा की जिम्मेदारी हमारे ऊपर है, और जितना भी बात करने का मन कर रहा हूं।
okay, after this you see in third and fourth, in third and fourth the stability order will be what? Which one is more stable if you compare third and fourth? In third and fourth, the charge separation is more over here, right? We have positive charge on nitrogen atom, positive charge on nitrogen atom, negative on CH2, right? So third and fourth, why the third one is more stable? Any logic, any reason for that? I think the options given here is wrong, I guess.
पता चलेगा तो आपको बताएंगे नहीं।
अच्छा सुनिए ना, आप एक बार तिवारी जी को
See, if we compare third and 2, right? So third and 2, if you compare, so obviously third one has more covalent bond, so stability of third is more than to that of 2, right? So 3 greater than 2, it is fine, right? 2 and 4, if you compare,
प्रमोद शुक्ला
2 and 4, which one is more stable? Maximum is 1. Tell me. Okay, see, I think the option given here, it is something wrong here we have, because 1, 3 and 4 will have more covalent bond as compared to the second one, correct? So obviously 1, 3 and 4 will have more stability than the second one. Second one should have the least stability, right? So second one will be least, 1, 3 and 4 will be more than this. 3 and 4, if you compare the stability of 3 and 4, I think the fourth one will be more stable. then we have third, and then we have 2, I guess. This should be the order. Why? Because fourth one, you see the charge separation is more over here, right? Here the charge separation is less. I'm not talking about the charge separation, the distance between the charge. If you see the number of positive negative charge, it is same for all the molecule. So charge separation in terms of distance, it is difference is there, but number of charges are same, right? So with charge separation, we cannot like the number of charges which is there in this molecule, we cannot decide. But here you see the distance between positive and negative charge is more. Oh, we have opposite, correct. One thing I have missed here. You see, first of all, the first one is most stable, right? But you see, the charge separation is more here, but the charges are opposite, correct? The charges are opposite. Charges are opposite. The opposite charge close to each other are more stable, right? So third one will be more. Like charges away from each other are more stable. That was the logic, right? Right. So first and then third. After this, we have to compare second and fourth, right? Second and fourth, you see there are two difference we have here. One is number of covalent bond, it is more over here, and the charge factor, right? Charge is what? The negative charge is present on carbon, and here the negative charge is present on nitrogen atom, right? So negative charge, if you compare what the first logic that we have, which is the number of covalent bond is more over here, right? Hence the fourth one is more stable than the second one, I guess. If number of covalent bond is same, then we see the charge present on the atom. Correct. Negative charge, negative charge we'll see when we have equal number of covalent bonds. Like you see in the first three cases, 1, 3, and 4, the number of covalent bonds are equal, right? So why we say the first one is most stable? Because the negative charge is present on most electronegative element, that is nitrogen. The first one is most stable. Third and fourth, if we compare, we have charge separation and opposite charges are there. The opposite charges are close to each other, more stable. So third is greater than fourth. Second one will be least because the number of covalent bond is least over here. So I think a little bit of change we should have over here. Fourth one and then the second one. Is it clear?
ชื่ออะไรหรอทำหน้าอย่างกับโดนเพื่อนทิ้งมางั้นแหละอย่าบอกนะว่าครั้งแรกอ่ะเดี๋ยวดิ
Fine. Question number 3. Question number 3, you tell me.
तो मैं फारल लाए मतलब बढ़िया सब बढ़िया इम्पोर्टेंट माल दे रहा है फिर काय माइनस बैठे हुए यार क्योंकि ऐसे होता है कभी कभी होता है आदमी का मन नहीं करता देखो भाई लेकिन हमारे साथ तो ऐसा नहीं होता है
यार हमारा गर्लफ्रेंड है गोरखपुर में
भाई बुलावा तुम तो कमाल हो यार हैं? अच्छा एक बात बताओ भाई तुमने सच में साई के आदमी को मारा था या धोखे से गोली चल गया
उनको नहीं
इसका जवाब भी तुम्हें कुछ दिनों में मिल जाएगा देखो सिर्फ एक बात समझो तुम्हें अपने अंदर से गोरखपुर वाला सिप निकालना पड़ेगा। वो कहा है कि जब तक तुम अपने अंदर से वो वाला सिप नहीं निकालोगे तो भोसड़ी के आगे नहीं बढ़ पाओ, चाहे यहाँ रहो वहां रहो, ज्यादा दिन तक जी नहीं पाओगे बेटा, समझे? इसलिए आगे बढ़ो बे, बाहर निकलो सारे सब चीजों से।
Background noise.
लो भी अभी मौज कर।
Oh yeah, some series was there actually. Okay, I'm sorry. It was there from the beginning only. Oh, actually, I was watching one series yesterday. So when I opened my laptop today, it was buffering in the background, so I could not see. Anyways, it is not there now. Now it's fine. Okay. Now you tell me the answer. Question number 3. Did you understand what he was talking? Okay. Okay, then fine if you did not understand. Anyways, tell me the answer. Question number 3. What is the answer? Why it is B? hydration energy released less than the ionization energy, then only the molecule will be in the ionic form. That's the logic, right? Is it greater? If option B is correct, then the energy released during hydration should be less than the ionization energy. Okay, just you calculate this. What is the hydration energy? Del hydration H. That would be for Al3 plus it is minus 4665 plus we'll have 3 Cl minus, right? So for 1 Cl minus is this. So 3 into minus 381 is the hydration energy. And what is the energy of ionization? It is given 5137. So this value is 4665 minus 3 1143. So that will be minus 5. So this is the hydration energy we have, right? So if you see this magnitude wise, the hydration energy is more, right? And the molecule, first of all, when AlCl3, if you put this into water that is in aqueous solution, it forms what? AlCl3 aqueous. So AlCl3 aqueous is what we have Al3 plus ion surrounded by H2O, 3Cl minus Cl minus ion surrounded by H2O, right? So when these two ion will remain in ionization in ionic form, right? Then the hydration energy magnitude wise it is more than to that of ionization energy. So first of all, this molecule will get ionized, okay, and then the hydration takes place. That's the logic, right? So if the del H of hydration, which is del hydration of H, if you add this value here, ionization energy, if this value is negative, or we can say if this value is less than 0, then the molecule will be in ionic form, right? Which is clear over here, minus 5808 plus 5137. This is less than 0, hence the molecule will be in ionic form, right? First, the energy required to convert this into ionic form is lesser than the energy released in hydration. Okay, so few the whole molecule will not convert into aqueous form, it will remain into the ionic form, hence the answer will be option B. If this is greater than 0, then it will remain covalent, right? Next question, question number 4. Question number 4. Usually, this type of question they do not ask in any of the exam, but you need to know this. There is just one formula we need to apply, and we'll get the percentage ionic corrected. Okay, so that's why I have given you this question. That formula, if you know, you can do this question. Try this one if you know the formula. Okay, you see the formula here. The percentage ionic character that we calculate is equals to 16 into, here the element is cesium and chlorine, right? So XCl minus XCS bracket close plus 3.5 into XCl minus XCS square. Okay, where XCl and XCS are the electronegativity of chlorine and electronegativity of cesium, right? So you always subtract the less electronegative element here. Chlorine minus cesium is square, right? Now the value you substitute and you will get the answer. 16 into 3 minus 0.8 plus 3.5 into 3 minus 0.8 square. Right? When you solve this, the answer you will get is around 52.14%. This is the percentage ionic character. Option D is correct. So the compound is ionic. Little bit of ionic character will have. So this formula, yes, you can use this formula if electronegativity is given, because this electronegativity you cannot memorize for all the elements, right? That's why these kind of questions they do not ask, but it is given there. So I have given you this question so that you can remember this formula, right? You must remember this formula. Nothing is required after this. All these value will be given in the question. Just you have to substitute the value and you'll get the answer. Understood? Question number 5. Tell me the answer. Fifth one is C. C is correct. MX3 sp2 hybridized. Okay. Next slide. This one, sixth one. Can you see the question, or I should magnify it? Zero dipole moment. D. D is not correct. Check your answer. D. Why not D? Why D is incorrect? NF3 has lone pair, overall dipole moment is not zero. SIF is a square planar. Yeah, that's the reason. You see, in all the molecules, CLF, first of all, you see CLF cannot have zero dipole moment, right? So we can eliminate this option C. Is this kind of question you can eliminate option easily. CS2, Cl2 will not have zero dipole moment again, because any sp3 atom, if you have, if all atoms or group attached with sp3 hybridized atom are same, then only the dipole moment for that molecule will be zero. sp3 it is, but we have chlorine and hydrogen. NF3 again will not have zero dipole moment here, because a lone pair present on the nitrogen atom. Correct? This option we can also remove. NF3, if it is clear, then this option we can also remove. And we are left with only B. This is by eliminating option, right? So you see the common thing over here, NF3. If you judge about NF3, whether it is zero dipole moment or not, then either you can neglect these two or you can select these two, like that. BF3 has trigonal planar geometry, right? Electron deficient molecule, no lone pair on it. So for this molecule, the mu will be zero, dipole moment will be zero, right? SiF4 again, it is tetrahedral, it is sp3 hybridized, or what it is dsp2 hybridized. You can check that. But in all the cases, whether it is tetrahedral or square planar, right? The dipole moment of SiF4 will be zero. Hence, answer will be option B. Yeah, it's correct. Right? So option B is correct. Question number 7. Yes, yes. Question number 7. Which bond angle theta would result the maximum dipole moment of a triatomic molecule XY2? It's simple, right? When theta is equals to 90, then the resultant dipole moment will be maximum, correct? Mu1 plus mu2. So it is option A. What is the resultant dipole moment formula? Mu r is equals to mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. And we know this thing will be maximum when this cos theta will be maximum, right? And cos theta maximum value is what? 1, which is at mu r will be maximum mu1 square plus mu2 square 2 mu1 mu2 cos theta. Yeah. So okay, fine. So this is we have, so when cos theta is equals to 1, when cos theta is equals to 1, then what happens? The value will be mu1 plus mu2. and when cos theta is equals to 0, which is when theta is equals to 90. So in this case, what happens? The angle increases from 90 to 180. When the angle increases, the value of cos theta will become negative, more and more negative, right? Hence, the resultant decreases. So actually, when you have when you have two uh, dipole moment or two vector given like this, then the maximum resultant of that vector will be at angle theta is equals to 0, right? At theta is equals to 0, the two vector will give you the maximum resultant vector. But here we don't have any 0 option, so we have to choose out of this 4, right? So from theta is equals to 90, beyond this value, this cos theta becomes negative, and here we'll have minus 2 mu 1 mu 2 something, right? That's why in the given option A is correct. Okay, otherwise in general, if in the board also they ask, the two vector will give maximum resultant when theta is equals to 0. Mu1 plus mu2 will be the maximum value of two, in this case we can say dipole moment or any vector. Anyways, question number 8. Suppose the observed value of dipole moment of H2O molecule is this. What will be the bond angle in H2O? Dipole moment is given, bond angle you have to find out. Little bit of calculation we have in these kind of questions. I have given you these questions because usually we don't solve this kind of questions. Dipole moment related question, resultant and all. That's why I have given you for practice. One data I'll give you, which will be given if this kind of question they ask. Cos theta, if it is 0 minus 0.2476, then theta will be 104 degree 20 minute. This value you should have in this question, and you have to do the exact calculation, because you see in this kind of question, if you get this option, then you have to do the exact calculation, because this difference is very small, 105 to 20 minute. And similarly for this one also, eighth one is A. You are getting, all of you are getting A. Just you have to solve this. Mu of H2O resultant will be what? Mu of OH square plus mu of OH square plus 2 mu into mu. This mu we have OH, 2 mu OH and OH cos theta, root over of it. So this cos theta you have to find out from this, because mu OH is given. When you solve this cos theta value, you will get this, and then the answer will be option A. Understood? Question number 9, you see. Question number 9. Okay, what is the answer? Ninth one is B. B is correct. So you have to basically find out the charge on H plus and H plus in both molecule it is given. So we know the dipole moment mu, this formula, again this kind of question we usually do not solve. Okay, dipole moment mu is equals to Q into D. This D is given for both molecule 127 and 161. Q we have to find out. Okay, the ratio of partial positive charge on hydrogen atom in HCl and all, right? So this D is given, so Q is equals to what? Mu by D, and mu is given 1.03 D by it is, right? So when you multiply this with 10 to the power minus 18, it converts into CGS system. The unit is ESU, electrostatic unit centimeter. This divided by the bond length, which is 127 picometer, and when you multiply it by 10 to the power minus 10, it also becomes centimeter. Right? So when you solve this, you will get 0.81 into 10 to the power minus 10 ESU. CGS system it is. What we can say, 1 D by unit is equals to 10 to the power minus 18 in CGS system. Okay. So Q by E, if you calculate, the fractional charge here. I'm solving only for this. Next one also you can do it in the same way. The fractional charge you have to calculate. So that will be equals to Q by E electrons. And in CGS system, the charge on electron we can write it as 0.81 10 to the power minus 10 as it is divided by 4.8 into 10 to the power minus 10 in CGS system. So you will solve this and you will get 0.168 approximately. Similarly, you do the same way and calculate fractional charge for HI. Take the ratio. The answer you will get is around 3.42 is to 1. That is B option. That is what you are getting, all of you. Right? So this is how we solve this kind of question. Not that tough, or there is no much concept into this, but you must solve one or two questions like this so that if it comes, you can do it easily. Right? Next question number 10. Solve this. Covalent character. We'll see what? We'll see simply the charge, right? Fazan's rule. So when charge is more, covalent character is more. So here we have plus, here we have the charge in the KCl we have 1, CaCl2 we have 2, 3 and 4. So according to the Fazan's rule, SiCl4 will have the maximum covalent characteristics and KCl will have the minimum. So you see the option, sorry. Anyways. See, option B is correct over here. All of you have done. Okay. Question number 11 you solve. Question number 11. Bond energy is given. Resonance energy you have to find out. This question they ask to calculate the resonance energy. Tell me what happened. Ritvik is getting B. You see the formula of resonance energy. Just a second. Just a second. रोटी दाल बना लीजिए, सब्जी अपना है। आप ये साथ नहीं किए तो रोटी बना Okay, so for resonance energy, you need to use this formula. Only one formula we have, that is del of, suppose the molecule is HF here. So del of HF will be equal to the bond energy of the molecule given. Here in this case it is HF minus root over of the bond energy of H2 from which the molecule has been formed and the bond energy of F2. This into this. Okay. So the bond energy of HF is what? It is given, everything you know, it is given in the question. It is 135 minus bond energy of H2, 38. Bond energy of F2, 135. This kind of question you will have. Sorry, it is H2, it is 104, right? For H2 it is 104 and for F2 it is 838. So when you solve this, you will get 72.14. Whatever the unit we have, that will be as it is. Answer will be option C. Right? Answer will be option C. So these kind of question, like in this, like when you have few days left, 7, 8, 10 days if you have left, just you try to see these kind of question also, which does not need any logic. It just want you to know this particular formula. All the data will be given in the question. Just use those data, use this formula, you'll get the answer. Okay. So you try to collect this kind of any chapter, any subject if you are doing. Try to collect this kind of information in the last few days. For benzene, again, you have to calculate the number of. For benzene it is different. For that you need few data here. This is the benzene. So for that you require carbon-carbon single bond and carbon-carbon double bond. This bond energy it requires. Right? And I have done this in thermodynamics. I have given you this thing, how to find out the resonance energy over there. So for that you will understand, because it is the average value of this. So we'll take the average of all these here. Carbon hydrogen bond, carbon carbon bond, carbon double bond, carbon. Okay, but in organic chemistry they won't ask you to find out the resonance energy, right? They will ask some concept related, some resonance concept related question, right? But this kind of resonance energy they will give you here in this chemical bonding chapter. Okay, when you remember this formula with this given data, you can find it out, right?
मिठाई उठाई कहाँ है गाड़ी लिए
मिलेगा, सब मिलेगा। Okay, so this is how we do. We don't have actually any expression here, right? But with when you have the question of benzene, they'll give you something called empirical resonance energy, and hybrid energy will also given, right? So we need to take the difference of those two. You will understand that only difference you have to take. But for that you require some data. We don't have such formula for benzene. They'll give you empirical resonance energy, they'll give you hybrid energy, they'll give you carbon-carbon single bond, double bond. With that, we can calculate. Either they'll give you this or they'll give you simply hydration and simply the energy of the hybrid structure and the empirical resonance energy. From that difference, you can find out. But usually with resonance, since we don't have such formula, such expression, they don't ask resonance energy to calculate for benzene. Okay, next question you solve. Question number 12. The smallest bond angle you have to find it, or I think it's clear. The smallest bond angle. Why NS3? Why NS3? Tell me. What is the reason? Tell me the reason why NS3 will have the smallest bond angle. Okay, one lone pair. What about H2O and H2S? How many lone pair? See, first of all, when you see the fourth option, it is SO2, which has linear geometry, right? So this cannot have the minimum bond angle. And all these three options is sp3 hybridized. So ideally, if there is no lone pair, the bond angle should be 198 109 28 degree, sorry, 28 minutes, correct? Ideally, but since lone pair we have present, then the bond angle will be less than this because of the lone pair bond pair repulsion. As the number of lone pair increases, bond angle also decreases. Because if you have this lone pair present here, right, this will suppress these bonds, right? So hence the bond angle will decreases. So obviously since H2 and H2S will have two lone pair of electron, the bond angle in these two will be lesser than to that of NH3. Is it clear? Right? So we are left with option A and B. Now in A and B, if you see, we have H2O and H2S. H2S. So first of all, the electronegativity of oxygen is more than to that of sulfur, right? And the size of sulfur is more than to that of oxygen, right? So because of size factor and less electronegativity also here, because the electronegativity of sulfur is less, the two lone pair of electron will suppress more to this bond here we have. But since the electronegativity of oxygen is more here, so this lone pair is very close to the oxygen atom, and hence the effect of this lone pair to suppress this angle will be lesser in comparison, right? That's why option B is correct over here. Did you understand this? This lone pair will suppress this bond pair of electron if the electronegativity is less. If the electronegativity of central atom is more, this lone pair is more close to the oxygen atom, and hence the effect to suppress this bond pair will be lesser. See what I said. Suppose we have any compound like this, and here we have two lone pair present. So this lone pair will suppress this bond pair of electron, and hence the bond angle will reduce, right? But the effect of this lone pair on this bond pair of electron will be less if the electronegativity of central atom increases. Why? Because if the electronegativity is more, this lone pair of electron is very close to this central atom, right? And hence the effect of this to suppress this bond pair of electron will be less, comparatively less, right? So what we can say, as the lone as the excuse me, electronegativity of central atom decreases, excuse me, electronegativity of central atom decreases, the lone pair will suppress the bond pair of electron more, right? And hence the bond angle decreases. That's why it is minimum for option B. Is it clear? You should not choose this C option. That was a shock for me when you said when all of you said option C is correct. You can easily see hybridization is sp3. One lone pair, two lone pair, two lone pair. So lone pair bond pair repulsion will be more over here. So less will be the bond angle. So any one of these two you can select. Okay, but when you said this, it was actually a shock for me. Anyway, so you take care of all these things. Okay, option B is correct over here. You can also memorize in another way. As the size of the central atom increases, bond angle decreases in the same group. Can we move on? Ramcharan is getting A. Ritvik, so most of you are getting A. Sanjana, Shweta, Mathli. A is correct. So I'm not discussing this, okay? You can easily find out the steric number, calculate the electron, divide it by 8, and then you can find the steric number. The answer A is correct. Okay? 21. D. XEF2. Only one I'll calculate. 8 plus 7 into 2 divided by 8. So it has 2 bond pair and 3 lone pair. Right? So 3 should be the first one, so D option is correct. Similarly, you can calculate for others. Right? Next one. $22. 22. All of you are getting B.
Option B is correct. Do I need to solve this? No, I guess all of you have done, right? 23. Anti-prismatic. See, anti-prismatic, actually it is not in our syllabus. Okay, but if when you have, since you have asked, I'll let you know. The square anti-prism is actually, it is an there are infinite number of triangles is there. The base will be in square, right? But there are infinite number of triangles. Okay, which is in set of the antiprism, and the number of triangles should must be the even number of triangle it is, right? So even number sequence of triangle sides closed by two polygon caps. Okay, it is difficult to understand like this. You just Google it. Okay, you will see the the structure actually of antiprismatic. Okay, uh, then you will understand. Will actually it has a square, and then with the square we have number of triangles are there, which is attached by the sides. Okay, and the number of triangles must be even number of triangles. That's the only thing we have in this. Okay, so it is it is difficult to you know excuse me, understand theoretically, but once you see the image you will probably understand. Okay, so better you Google it, you will understand that. 23rd, most of you are getting A. The molecule shape this R, right? So you see this kind of questions you can solve easily. 23rd A is correct. I am not discussing this also, right? 24th, you tell me. Tell me 24th. Polar and sp2 hybridization. A. B and C is obviously not the answer. And the structure of HClO2 is what? It is Cl double bond O and OH. Okay. But the structure of H2CO3 is this C double bond O, OH and OH. Right, dibasic acid, sp2 hybridization, and polar also. D is this Cl double bond O, OH. Understood? HClO2 is an acid, right? So H is attached with oxygen over there and Cl with double bond O. Option A is correct. Fine. Question number 25. Tell me the number of bond pair and lone pair. I3 minus is important. It has been asked in the exam. Okay, some of you are getting A, some of you are getting B. Okay, tell me what is the geometry and shape of I3 minus? Shape is linear. What is geometry? Shape is linear, it's correct. Geometry, you tell me? How many electrons I3 minus has? 7 into 3 plus 1 divided by 8. So it has 2 bond pair and 3 lone pair. Right? So obviously 3 and 2, option A is correct. Right? The shape will be linear and geometry will be trigonal bipyramidal. It is like this. We have one lone pair here, another lone pair here, and another lone pair here. I will have here I and I. and this is forming a triangle here, like this. This is a triangle, and this is the 3 here. 3 lone pair at the vertex of this triangle, right? Geometry is trigonal bipyramidal. Shape is linear. 3 lone pair and 2 bond pair. Question number 26. Hybridization. All of you are getting B, and option B is correct. 26, option B. 27th. The d orbital involved in sp3d hybridization. What is the geometry of sp3d? See, if dz square orbital is there, then the geometry must be octahedral or square bipyramidal, because dz square orbital has 2 lobe, right? Like this. If it is taking part in hybridization, this must be also like involved in bonding. So the geometry should be square bipyramidal when dz square is there, right? This is actually a factual based question. The answer for sp3d hybridization is dzx. In this orbital, dzx d orbital is involved. If the dsp2 orbital is there, then the d orbital involved is dx square minus y square. Okay, sp3d dzx, dz square involved in octahedral complex sp3d2. Fine. Answer is option B. Understood? Can we move on? Okay. Question number 34. Which of the following species does not exist? We calculate bond order in this, right? If bond order is 0, the molecule does not exist. Right? Option C is correct. This one, diamagnetic molecule. Superoxide. Why some of you are saying A option, superoxide? Option C is correct. Oxygen molecule O2 we have already seen. This is paramagnetic. Molecular orbital theory, right? Paramagnetic, right? Superoxide ion is O2 minus. This is also paramagnetic. 8 into 2 plus 1, 17 electrons. This is also paramagnetic. Carbon molecule is C2. This is diamagnetic. You can check. And then unipositive nitrogen molecule, that is N2 plus. This is also has 13 electron, so it is also paramagnetic. So option C is correct in this. Yes. 36. 36. Boiling point order. Condania is getting B. I have discussed this yesterday or day before, I think. Sanjana is getting B, Mathli is getting B. Yeah, exactly. Not the same question. I think the same question or what? Okay. So here we have intermolecular hydrogen bonding, right? Intermolecular hydrogen bonding. And for intermolecular hydrogen bonding, the order will be this. Maximum we have for para, then we have meta, and then we have ortho. So 1,4 will have maximum para, 1,3 will have meta, 3, 2, 1, and then 4. Right? So 3, 2, 1, and 4, option B is correct. Yes. 37. Tell me. Strongest hydrogen bond in vapor phase. In strongest hydrogen bond is possible when we have maximum electronegativity difference, right? That is possible in the case of fluorine and hydrogen. So option A is correct. Okay. Next question number 38. Question number 38. Oxygen, hydrogen, right? The most electronegative difference we have. So 38, option C is correct. Oxygen, hydrogen will have the most electronegative difference. D is not possible. You see, we have hydrogen molecule here, Purvik. So we don't have any charge separation here. It is covalent, completely covalent. That's what H2 molecule. See, when hydrogen bonding is possible, when we have HOH and another molecule will have hydrogen. If there is charge separation, this should have positive and this should have negative charge. Then only this. Um, Sorry. So positive, we should require some negative charge here. But in the case of H2, we'll have HH bond, right? We don't have any charge separation in these two. That's why this hydrogen bonding is not possible. Correct? Okay. Question number 39. This question is also based on hydrogen bonding. Most of you are getting C, some of you are getting B, D. Why C is the answer? The answer is C, right? But why C? See, KHF2 molecule. Yeah. See, KHF2 molecule will exist like K plus and HF2 minus. This negative charge will be there on the one of the fluorine atom here, right? So this F minus will form hydrogen bonding with this HF, right? That's why this molecule exists in this form. When KF combines with HF to form this, and because of the hydrogen bonding, it exists in HF2 minus and K plus will be there. Yes, Cornelia, correct. That's why HF2 minus will have. So this is also one another type of question we have, which is based on hydrogen bonding again. Ionic bond is stronger, yes. Ionic bond is stronger here, always stronger than the hydrogen bond. See what happens here. Kf will actually exist in K plus and F minus. And this F minus, because of this electronegative difference here, we already have H plus and F minus. So this also has tendency to make a hydrogen bond here, right? And the molecule will exist as K plus and HF2 minus. Kf is a strong electrolyte, right? Like KCl. It will exist in ion forms. And the second molecule, HF, electronegative difference is there. So charge separation will be there, and hence the hydrogen bonding is there. Right? Option C is correct. Question number 40. What is the answer? C is obviously correct. Chemical bond always forms when the force of attraction is more than the force of repulsion. Then only it will overcome. Right? Absolutely pure water does not contain any ions. Not true. It has ions. H plus and OH minus will be there because of the electronegativity difference. Okay, so option C is correct here. HF is obviously more polar than HBr. In covalency, there will be sharing of electron, not transfer of electron. C option is correct. 40, question number 40, option C. Question number 41. Metallic luster exhibit by sodium is explained by Proton is not possible. Diffusion of ions also not possible. Metallic luster is because of the electrons, right? So only one option is there. Oscillation of loose means what? The movement of the electrons or loose electrons. So obviously option C is correct here, right? Next one. These are the previous year questions. Yeah, it causes color, but here the question is metallic luster, right? So the metallic properties of any metal we have, that is because of the electrons, not ions. Okay, electrons, not the cations or positive ions. Okay, I'll see the previous question. The question is what? Metallic luster means the metallic layer that you have, or you can say the metallic properties of that any metal if you have. That is because of what reason? That's the question. Color thing is there because of the ions, right? But metallic nature is only because of electrons, because of movement of electron. That's why it is oscillation of loose electrons. Movement of electron only we have metallic nature, right? Okay, now you see the next one. Question number 46. 46. 46 is B, it's correct, right? Because you see this I3 minus is made up of one iodine molecule and I minus, right? Linear, just now we have discussed shape is linear, and with this I minus, this CS plus has joined, right? So that's the complex compound. It is kind of the complex compound we have. That's why option B is correct. You must keep this in mind. This is important. Not 3 minus you 3I minus you, right? Okay. 46th one is B. What about 47th? Few questions we have already discussed in this. You must try to figure it out, like what kind of question they ask in the exam. 47, you are getting B. IF5 is unsymmetrical. Right, but it is pentagonal pyramidal, it is. Pentagonal shape we have of this, right? So 47, option B is correct. All of you are getting option B. 48. SBF, what is the shape? What is the, try to find out the geometry of SBF5. Tell me the geometry of SBF5, all of you. What happened? SPF5, the trigonal bipyramidal. Yeah, it's correct. Trigonal bipyramidal, and that's why we have symmetry over here, right? And because of this symmetry, the dipole moment, net dipole moment will be 0. Right? So symmetry we are just checking. 48. 48. Yes, what is the answer? Question number 48. IF5 you're talking about. Chlorine is more than iodine, right? And yeah, it is covalent. Isn't that how you find boiling point and lone pair non polar means dipole moment not zero, right? Okay. Okay, see this in this IF5, see in this IF5 there will be a bit of, see if the molecule is covalent, right? If the molecule is covalent, but still if they have electronegativity difference, because you must have seen the ionic nature and covalent nature, the electronegativity difference will have a specific value. More than that, it will be ionic. Less than that, it will be covalent, right? But in that also we have few exceptions, right? If the bond is covalent also, but still it is iodine and fluorine, we have huge electronegative difference and size difference also, right? So because of the both factor, size and electronegativity, still we have little bit of charge separation that will give you the dipole moment, which is not, net dipole moment is not zero here because the geometry is not symmetrical. That's the reason. See, one bond can be polar or non-polar, but when you are talking about a molecule, we have to see whether we have, because of the one bond will have dipole moment, right? But for dipole moment for a molecule, if you are talking about, then we have to check whether we have net dipole moment or not, right? So in that you have to consider all the bonds which is present in the molecule. Question number 48, option C is correct. It has 4 d pi p pi bond. The structure of XeO4 is this. Xe double bond O. This is a structure. So D P 4 d pi p pi bond is there. Option C is correct. What about 49? How do we do this? Option B is correct. Saundarya, how did you get option B? Sanjana, how did you get option B? Ramcharan, how? Atmesh, Kushal, all of you are getting option B. How is it option B? See, it says that bond order is same, but they are not equally stable. So in this type of questions, we'll just check how many electrons, how many electrons are present in anti-bonding molecular orbital. So the concept is what? As the number of electrons in anti-bonding molecular orbital increases, stability decreases. That is what you have to find out. Stability decreases. Yes, anti-bonding electron. So you just write down the electronic configuration of H2. It has 2 electron, so sigma 1s2. For Li2, it has 6 electron, so sigma 1s2, sigma star 1s2, sigma 2s2. Then we have B2, 10 electron, so sigma 1s2, sigma star. Obviously in B2 we have more anti-bonding electrons, right? So maximum anti-bonding electrons. So stability of B2 will be minimum and H2 will be maximum. So option B is correct. Number of anti-bonding electrons will check. Question number 50. 50 and 51, both you tell me. Fifty is C. C is correct. If you have any doubt, you can ask me. Okay, I'm not doing these kind of questions because these are very basic and easy questions we have. 50 is C, it's correct. What about 51? The shape of IF6 minus. 50, so 50 by 8, 6 and 1, 7. So it's not pyramidal, it's not octahedral, it's not the square antiprism. It is distorted octahedral, triangular distorted octahedral. What is the hybridization? Option A is correct. What is the hybridization, you tell me? You see, for a square antiprism, the steric number should be 8. Then only it is square antiprism. And if steric number is 8, it also involves f orbital. Sorry, not f, it will be sp3. See, anything is possible. You cannot say sp3d3 is fine till 7, but after that you have to draw the electronic configuration, and then according to the compound you'll see what is the next orbital we have which takes part into the hybridization. So usually we discuss only till sp3d3. Beyond that is not in our syllabus. You will not get questions of this. But since the question is given, it is enough that you should know that if the steric number is 8, then only the shape will be square antiprism. And with 8 steric number, we have sp3d3. 7 orbitals are there. What will be the 8th orbital? It depends on the molecule according to its electronic configuration. According to that only we'll see which is the next orbital which can take part into hybridization, so that its steric number should be 8. So according to that, you have to think, right? So like this we cannot say. Maybe f orbital is there, maybe we have some inner orbital also involved, anything possible. So you cannot say like that. But if you have 8 steric number, a square antiprism you can choose, which is not obviously in this case, because the steric number is 7 you are getting here, and with one lone pair, right? That's why it is trigonally distorted octahedron. A is correct. 52. I have discussed this question. 52 I have discussed. See, all these contains weak field ligand. DSP2, it is actually the question of what we say, coordination compound, but there also we have hybridization. So this may ask in, may give in this particular chapter also. All these are weak field ligand. DSP2 is possible when we have uh, pairing against the Hunstool, and that is possible in the case of strong field ligand, right? But since all these are weak, but in case of palladium, what happens, because of large size of PD2 plus, the pairing is possible. I have discussed this that day when we were discussing coordination compound. So here the answer will be option A. Yes, we have discussed this because the size of the palladium ion. 51, the hybridization C, IF6 minus the number of electrons here we have, you see, that is 7 into 7 plus 1 divided by 8. So that will be 50 by 8, 6 bond pair and 1 lone pair. So hybridization will be sp3d3. 6 bond pair and 1 lone pair, sp3d3 for option A. For this, the last one, we have only the information that its steric number should be 8. Hybridization, it depends on the compound we have. 52 is A, we have discussed this, right? You must remember this particular question. Large size of palladium leads to the pairing of electron against the Hunstool if the ligand is weak ligand also. 53rd. Okay, we'll start from this question. 53rd, you let it be now. 53rd will start from here after the break. We'll take a break. I'll take my break first now. Okay, so we'll start in 15 minutes. 11:30 we'll start. Okay, fine. Let me know quickly. 11:30 we'll start. We'll have half an hour more. Okay, we'll start at 11:30. Okay, can we start now? '53 is D. Okay, answer is correct. D option, but here we use different formula because here the bond energy and all is not given, right? But bond length is given and then dipole moment is given. Okay, so in the form of in with dipole moment, the expression of percentage ionic character, I'll just write down the formula, can be given as mu observed divided by mu calculated into 100. How do we calculate this mu? This mu we can calculate. Mu observed is given in the question. It will be E electron into distance. Electron charge we know already, 1.6 into 10 to the power minus 19. And the distance is also given, 9.17 into 10 to the power minus 11. Okay, in all these kind of question, you must take care of units. Okay, so this thing will use, and when you substitute this here, mu observed is given, you'll get percentage ionic character. Option D you will get as the answer. Okay, so this is one formula, and the another one we have also discussed. These two formula you must keep in mind to calculate percentage ionic character. Maybe on the previous formula they may ask you some question, because this formula they have asked once in 13. So the previous one they may ask you one question on that. Okay, so you must keep that in mind. Stability of the species of this. How do we do this? 54th. Tell me the answer. 54th. Tell me the answer. 54th. You are getting A. 54th A is correct. We have discussed this kind of question. What we'll do, we'll calculate the bond order. Correct? More bond order, more will be the stability. If bond order is equal, right, then we see the number of electrons in anti-bonding orbital. If the number of electrons in anti-bonding orbital is less, is more, stability will be less. Do I need to solve this? 54th A is correct. Option A. You want me to solve this? Then let me know, please. See, Li2 minus and Li2 plus has equal bond order, right? Right, Soundarya? Equal bond order. So when the bond order is equal, just you check the number of electrons present in antibonding molecular orbital. If the electrons present in antibonding molecular orbital is more, stability will be less. Understood? So in Li2 plus, if you see, there are 2 electrons present in antibonding molecular orbital. But Li2 minus, there are 3 electrons. So stability of Li2 minus is less than to that of Li2 plus. Correct? Next, question number 55. D we have just now we have done. What about A? Purvik, how it is B? Ritvik, how it is B? Oxygen is paramagnetic in nature. That is how we get molecular orbital theory. Purvik and Ritvik, how it is B? Oxygen has 16 electrons, fine. But when you draw the electronic configuration according to the molecular orbital theory, oxygen molecule is found to be paramagnetic in nature. It has unpaired electron. And that is how we have got the molecular orbital theory. Yes, A and D are correct. You see, the question is what? Is R expected to be exhibited? Right? Vaishnavi, your answer was correct. A and D. N2 and C2. You draw the molecular orbital. No. It doesn't mean that is expected to be. O2 and S2 both are paramagnetic. It simply means that which of these are diamagnetic in nature. Right? So you draw the electronic configuration of N2 according to MOT. NO2 and N2 has 14 electrons. You draw the structure, you will understand. C2 we have just now, we have seen. Just you check for nitrogen. O2 we already know it is paramagnetic. And so S2 also, both belongs to the same group. No issue, Purvik. Tell me. N2 is diamagnetic, yeah? Yeah, so A and D are correct. N2 and C2. 54th one is A. 55th one is A and D. So whenever you have this kind of question, is R when it is there, you have to check all the options. Okay? Take care of this. Yeah, so N2 and C2 are correct. A and D. Tell me question number 56. Again, not likely to exist means what? Bond order should be 0. You can calculate the bond order easily. Option C is correct. 57. Is B. 57 is also correct. So you see in all these questions which has been asked in JEE exam, you see none of these are tough. All are easy questions. And whoever made some mistake here, that is the mistake has been made, that those are casual mistake actually. So when you read out the question properly, see the options properly. What is the question saying? What could be the answer? Like in this one, 55th one is or it is there. So you have to check all the options. Maybe more than one correct in these kind of questions. So you have to take care of these kind of questions, right? So basically, the point I'm trying to make is what we have solved around 50 questions in this, more than 50, I guess, 50 to 60 questions we have solved. And you must have felt that these 15 questions or 10, 12 questions that we have done just now, previous year questions, these are the most easiest questions we have done, right? So it is not like that they ask tough questions in the exam. Okay, just you read out the question properly, and you have to be very focused, right? Basic thing you should know, and while marking the answer you have to be very focused that what is the question, is there more than one correct, is there or not, what is the exact language of the question. So you better you take care of those things. Don't make any silly mistakes. Usually because of silly mistakes only, you have to suffer in the last. Okay, so when you are solving some questions, try to avoid those mistakes, calculation mistakes and all. Like you said, got confused with the language of the question. So to understand the question also is a kind of test that the examiner take. Okay, so you have to understand the question, then you have to solve the question and get the right answer. Anyways, so this is for this chemical bonding we have discussed. We'll solve some questions on atomic structure now. This one. Vaishnavi is getting D. Is it D? Vaishnavi, check your calculation. Check your calculation. Sanjana is getting A. Vaishnavi is again getting B. B is the correct answer, Vaishnavi. Sanjana, you check your calculation. Okay, you see, the critical wavelength for producing the photoelectric effect tungsten metal is this. Critical wavelength means what? This is the wavelength corresponding to the work function of the metal, which is nothing but the lambda naught. Okay. Now, the equation of photoelectric effect is what? H nu incident is equals to H nu naught plus the Ke max. This is nothing but the work function. So kinetic energy is what? Nu in we can write Hc by suppose lambda 1 minus Hc by lambda naught. So according to the question, this lambda naught is given 2600. What wavelength should be necessary to produce photoelectrons from tungsten having twice the kinetic energy? Those would produce at 2200 angstrom, right? So the kinetic energy, suppose according to the question, at wavelength lambda 1 is equals to the kinetic energy at wavelength lambda 2, where the lambda 2 is what? Lambda 2 is 2200 angstrom according to the question. Right? Now this will substitute here. So here the kinetic energy will be Hc by lambda 1 minus Hc by lambda naught. Sorry, we have 2 into this according to the question. So 2 into Hc by lambda 2 minus Hc by lambda naught. Right? This is what the equation we have. All these Hc will get cancelled. Right? Lambda 2 is given 2200. Lambda naught is given 2600. This is also given 2600. This you have to find out, lambda 1. So this equation you have to solve, and when you solve this lambda 1 you will get 1907 angstrom. Understood? Option B is correct. So you see one more thing here in this question, that you see the options are very close, B and C. So you don't take any approximation here, right? Do the exact calculation when the options are close like this. Okay. Question number 10. Tenth. All of you are getting A. Tell me others. Option A is correct. And if you want me to solve, let me know. Otherwise, since most of you are getting, I will not solve it. But you let me know, any one of you, if you have any doubt, you let me know, I will solve it. Energy required to stop the ejection of electron from Cu plate is 0.24. The radiation is this nanometer strikes the plate. The work function is stopping potential is given. Just you need to use the equation. Calculate the energy that is incident onto the plate, which is nothing but hc by lambda. Lambda is given. That energy is incident, right? That energy is incident. From this, we'll calculate energy E, which is equals to hc by lambda. This energy, and out of this energy is used for the stopping potential. So work function plus this is equals to this energy, right? So whatever this you are getting, this minus this will give you the work function, right? One thing you have to take care here, when you use this expression, E is equals to hc by lambda, right? The energy you will get in joule. But since this stopping potential is given in electron volt, so either this you have to convert in joule or this you have to convert in electron volt. So since the option is given in electron volt, so best way is to convert this into electron volt, right? So 1 joule for this, if you have to convert into electron volt, E we have to divide it by 1.602 into 10 to the power minus 19. This becomes the electron volt. Now this minus 0.24 electron volt gives you the answer. So answer you will get is option A here. 11th also you have done. Question number 11. 25 watt bulb, I mean, it's a very common question. Okay, you have to find out the rate of emission quanta per second. 11th you are getting A. Option A is correct. Energy will calculate hc by lambda, right? And the watt and the power is equals to what? The number of photons emitted per second into the energy of the photon, right? So whatever value will calculate, that is nothing but the power, and that will divide by the energy of the photon. You will give you the quanta per second, right? Option A is correct. See, in atomic structure, unit is very important. You know everything, but once you miss out the unit thing, you'll get a wrong answer, and that will be there in the option. The unit you must take care of, the conversion thing you must see, and all those things you have to keep in mind. Next one. So these are the three questions that we have discussed. There are three different kind of question, but the concept is what? Concept is photoelectric effect only. Okay, so those three different kind of question they ask in photoelectric effect. Okay, so that is what you have to keep in mind. Question number 19. 19th you are getting B. Right. Only formula you have to use option B. Question number 20. Question number 20. Question number 20. Again, you are getting B. All of you are getting B. So I will not again solve this. B is correct. Question number 21. What is the N value for second excited state? N is equals to 3. Okay. Fine. Calculate. E value is given 1 mole of hydrogen atom. Means Na atoms we have to shift, right? So option you see, the energy is given in electron volt. Option is given in kilojoule. So that electron volt you convert into kilojoule first. Joule first. Purvik is getting D. Correct, Purvik. D option is correct. So first of all, this 12.084 we have to convert into joule, and that will be 1.6 into 10 to the power minus 19. This is joule for one atom, per atom. 1 mole of atom we have means Na atom, means this we have to multiply by Na, right? So 12.084 into 1.6 into 10 to the power minus 19 into Na, Avogadro number. This is joule per mole. And then we have to convert this into kilojoule in the last. Answer you will get 1164 kilojoule. Only unit conversion we have here. Like I said, unit conversion is very important in this chapter. Question number 22. Question number 22. What is the value of N1 and N2 for Lyman series? Shortest wavelength. N2 is what? The final Ni is equals to what? And what is Nf? Lyman series, the electron comes into first energy level, right? N is equals to 1. So Nf is 1, and since shortest wavelength we have to find out, so Ni should be the maximum value, which is nothing but infinity. So 1 by lambda minimum is equals to RH Z square. Why Z square? Because we have helium here, He plus, divided by 1 by 1 square minus 1 by infinity square, whatever it is. Z value is what? For He plus, Z value is 1. So when you substitute this, so RH you will get from this. RH is equals to 1 by X according to the question. Now the same thing we use for Balmer series. Okay, it is for hydrogen atom, so it's 1, fine. He plus. So for Balmer series, the wavelength is not given, we have to find out. So longest wavelength 1 by lambda max is equals to RH Z square. For Balmer series, it is 1 by 2 square minus 1 by 3 square. NF minus NI. RH is given 1 by X, and when you solve this, you will get 1 by lambda max is equals to 5 by 9x. So lambda x will be 9x by 5. 22, option A. Yeah, option A is correct. Question number 23. Question number 23. What is the velocity and orbit relation? V in nth orbit is inversely proportional to n. Right? So what we'll write? V in first orbit divided by V in third orbit. It will be 3 by 1. Right? So what we have to find out? Speed electron third orbit. So V3 is equals to what? V1 by 3. So x by 3 it is. So option B is correct. 24th. Use the energy formula E2 minus E1. E2 minus E1 you have to find out. 24th one. See, the unit is joule per mole. So accordingly, you'll write the expression for energy. (9.84×10⁵). It's correct. 24th B is correct. Only formula you have to use. Any one of you, if you want me to solve, let me know. I'll do this. Kondania, what happened? Where is Ramcharan? Okay. Did you get the answer, Ramcharan? Okay, you see, joule per mole we have here, and the energy formula we have is in joule per mole if I write. So En is equals to minus 1.312 into 10 to the power 6 by n square. Because you see here what is given, the ionization energy of hydrogen atom is this. Ionization enthalpy means what? One electron you have to take from, since we have this ionization energy, so we are talking about first ionization energy here. So from E1 to E infinity you have to take. Means from the first orbit electron you have to take at infinity. That is nothing but the removal of electron or ionization energy. So that will be E infinity will be what? 0 minus E1. So that will be minus E1, and which form value is given is minus 1.312 into 10 to the power 6 joule per mole. So in En, this divided by n square will be the energy. Now we have to find out E2 minus E1, right? The energy required to excite an electron in an atom from 1 to 2. So from first orbit to second orbit you have to go. So whatever the energy difference we have here, that we have to find out. So what we'll write, E2 minus E1 is equals to what? This formula will use minus 1.312 into 10 to the power 6 open bracket 1 by 2 square minus 1 by 1 square. This is what you have to solve, right? And answer you'll get approximately around option B. Understood, Vaishnavi? Okay, last question, 25th one, last one for today. 25th. The wavelength of a neutron with a translatory kinetic energy equal to this at 300 Kelvin is. What is K? K is not mentionable. K is Boltzmann constant. KT, K is Boltzmann constant. You see in this one, K is the Boltzmann constant. It's not mentioned here, but it is a Boltzmann constant. So kinetic energy it is given, that is KT, where T is the temperature. This will be equals to, Boltzmann constant is R by N naught Na into temperature. Now R value you know 8.314, temperature is 300, and Na value you have 6.02 into 10 to the power 23. And when you solve this, you'll get the value of kinetic energy is 4.143 into 10 to the power minus 21 joule. This is the kinetic energy. And we know the mass of a neutron is what? It is 1.67 into 10 to the power minus 27 kg. Unit you must take care of. Again, I am telling this. Okay. And kinetic energy we know, but we have to find out. We have to find out the wavelength. So wavelength is equals to what? H by mv. H we have, right? And this we can convert into in the form of kinetic energy, and that will be H by 2m into kinetic energy, root over of it. In this you see everything you have kinetic energy, you have H value, you have mass. Put this and you will get the answer. The answer will be approximately 178 picometer. Understood this? Fine, got it. Okay, okay, so we'll wind up the class here only. Okay, tomorrow, if you have class, chemistry class, I will let you know, because I have to take 11th class tomorrow. Class 11th I have to take tomorrow. So if you have class, I will let you know. Otherwise, we'll send you the schedule, by the way. Okay, whenever you have class, we'll send you the schedule. Right? In organic, you must solve. I have sent the questions on D and F block element. Right? You must have seen that there are sections, different sections. Like this is for the compounds of iron. This is for the magnetic properties, KMNO4. So on the basis of that, they have given few questions section wise. Okay. So I have given that question. I have sent that questions with answer key also. You must go through with that. In organic, every day you read 3-4 pages now also with some questions must you see, because you never know, suppose last day also if you read one particular line, they may ask that particular line only in the exam. Okay, so last days, 5-10 days, that whatever you have, you try to gather the information, that is it. Okay, don't try to read or understand any new concept. Okay, so fine, we'll wind up the class here only. See you soon. Okay, bye bye.